Today we are going to look at the forms and features of a quadratic equation. We have 3 forms, and each of the forms reveal a very unique feature of a quadratic equation. The quadratic is in the standard. We have the y-intercept. The constant is always the y-intercept. And then we have vertex form, which also reveal the vertex point. Another way can also help us to get axis of symmetry. And then we have the factored form or the intercept form. That one also reveals the x-intercepts or the solution or the roots of the equation. So we have been given, this is a factored one. We want to change it to a standard. So what we are going to do is that we are going to expand, which we are going to use a FOIL to expand this. First, we multiply the first one. We didn't do nothing with the 2, so we bring it out. X times x give us x squared. And then we multiply the outer, which also give us negative 3x. And then we come to the inner, multiply, and last one. We multiply and that gives us negative 15. The middle is like term. So let's combine that. We get plus 2x minus 15. We want to be in the form of this. So we also distribute the 2 over here. Multiply each of them by 2. From the factored, we have able to change it to the standard. Now we are going to go to convert the standard into the vertex. And we are going to use this one because we need our h and k. So we are going to use this formula here. There is a lot of ways to do that. We can use a completing square, but we are not there yet. Let's use this one to find our vertex point. H is going to be negative b over 2a, and this is a, B, and C, so which implies that our h is equals to negative 4 over 2 times 2, which become 4, negative 4 divided by 4, which is negative 1. So our h is negative 1. We're going to plug this into here to get our k. So we get y is equals to 2 times, wherever we see x, we replace it with negative 1. The square here. This will become negative 1 times negative 1 is going to be positive 1. So this become 2. Here will become negative 4. Here negative 30. And when we do that, we will get negative 32, which is equals to the k. We are going to use this formula to write the vertex form, which is going to be y is equals to, remember the a was 2, so 2 outside. And then x, our h was negative 1, but the formula have negative, so negative become positive 1, right? And then the k we got to be 32. So we have able to rewrite or convert the factored form to the standard and then to the vertex form. And each of them reveal a very unique information. As we have said here, it revealed the x-intercept, so you can boldly say that x-intercept here is going to be negative 5 and 3. It's always switching. And then here we can say that when we graph it, our y-intercept is going to be negative 30. And then here it reveals the axis of symmetry. We can say the axis of symmetry is going to be x is equals to negative 1. It's always opposite when you're coming that way. I'm going to graph this for you to see information as I'm talking about. All right, guys, let's graph all the equations that we have able to get all the information. So this one was the given, which happens to be in the factored form, and we said that the factored form give you the x-intercept. Okay. So this is the solution of the quadratic equation. Give you right there. And then we're able to also change it into this one, which is a standard. You could see that all of them are going through the same path, because if I take this one off, you see the path is still there. It's the same path. And then we bring it back. They are all going through the same path. And here you can boldly, without doing nothing, you could see that, oh, this is a y-intercept. You come here, indeed, that's the y-intercept right here. Negative 30. The last form, that was the factored form, which happens to be this one. x plus 1 close it squared n minus 32. You see, that one is also going through the same path. So all this thing is equivalent. We're changing it from one form to another. And each of them is reviewing a special feature of a quadratic. It's reviewing a special characteristics of the quadratic. Here, we said that this one is reviewing the axis of symmetry. So the axis of symmetry, you could see, is this line. Let me draw that line. You can see it's x is equals to -1, as we said. X is equals to -1. And you see that line divided this parabola into two equal sides. So here you can boldly say x is equals to -1 is the axis of symmetry. And that's all about changing it from one form to another. Thank you very much for sticking with me to the end. Please subscribe if you haven't done so. Give me a thumbs up. See you later. Bye.